Hey kids. Alright, we're going to do a little projectile problem here. I have a ball. It's being kicked from the ground at a speed of 25 meters per second. Pretty fast kick, 50 miles an hour. At 40 degrees above the horizontal. We want to figure out how high it goes and the range. Okay. As always with our physics problems, you want to follow the steps. So our first step is going to be to draw a path. So here's the path. It goes and then comes back down. Because you're kicking it from the ground and it's returning from the ground, that the starting point, the ending point is the same. Okay. I usually label some points along the path, A, B, and C. So starting point, peak, and then the ending point. A couple things just to remind you about. Okay. Point A is not when it's sitting on the ground. This is the instant after it's left your foot. Point B is the peak. And then point C is the instant before it returns to the ground. The reason that's important is because if it's sitting on the ground, then the only force acting is not gravity. The ground is also acting. And this is projectile problems. The only force acting is gravity. Okay? But there's our picture. Okay. Then our next step is, as always, we want to write down our givens. So we have horizontal givens and we have vertical givens. So you need to split them up into horizontal and vertical givens. You got to be careful. 25 meters per second at 40 degrees above the horizontal. Is that horizontal? No. Is that vertical? No. It's actually both. So what are we going to have to do? That's right. We're going to use our knowledge of vectors and find the components. Okay? So I have 25 degrees, 25 meters per second at 40 degrees. So if I do some math, sine 40, you get this one is 16.1 meters per second. And this one is about 19.2 meters per second. Okay? Okie dokie. So now then, where do we put that into our chart? Okay? Well, this is how fast it's going initially vertically. So at point A, it's moving 16.1 meters per second up. Okay? So that means my initial y velocity is positive 16.1 meters per second. Okay? At point A, my x velocity is 19.2 meters per second. But the nice thing, remember, horizontal velocity is always constant. So if I was to ask you, hey, what's the horizontal velocity at point B? It's this. If I was to ask, what's the horizontal velocity at some random point here? It's the same, because horizontal velocity is constant. The only force acting is gravity. Gravity only affects vertical motion, okay? But, so that means this is really VO and V, so it's my initial and final and everything in between, is 19.2 meters per second. And then, as far as my other stuff that I know that this I don't know. Well, maybe I will in a minute. We'll talk about that. I am looking for my y displacement, but here's where you have to think about this. I'm looking for my y displacement at which point, if I want to know how high it goes. Oh, that's A to B. So I'm going to write myself a little note. I'm looking for this, but I'm going A to B. If I'm going A to B, I know something else. At point B, it doesn't move vertically because it slows down and then it stops. Now remember, it doesn't stop completely. Is it moving at point B? Yeah, it's moving horizontal. Okay? But the vertical velocity is 0, so that's 0 because I'm at point B. At B. Okay? If you want, that's at A, because again, I'm going A to B. My acceleration, because I'm on Earth, is negative 9.8 meters per second squared. We're over here. I am looking for my range, but here again, you got to be careful. Range is from A to C. Oh, so this is A to C. So just be careful with that. So then, all right. I don't know my time, and then over here, my A is 0 because the only force acting is gravity. Gravity is only going to affect the vertical side, and then my time. Okay. All right. So again, I want you to think of this as the Great Wall of China. So givens over here, you have to keep over here. Givens over there, you got to keep over there. Horizontal motion, completely independent of vertical motion. All right. So if I want to figure out how high it goes, I need to know this. If you want, I could just plug stuff in and solve. So if I want to use my equation, I just want to make sure you can see. So I'm going to pick up my equation, which is going to be v squared equals vo squared plus 2ay. Plug my numbers in. 0 squared equals 16.1 squared plus 2 times negative 9.8 times y. And you can solve that for y, and you get 16.1 squared divided by 19.6. You get 13.2 meters. So that went really high. Okay, but again, we kicked it really fast. And then now if I want to find my range, okay, so I'm going to come over here and go, all right, I want to find my range. If you look, well, this is 0, so that means I have constant motion. Anytime you have constant motion, the equation you can use, I'm going to erase this just so clear it up. The equation we're going to use is, v equals d over t. Okay, or if you want, v equals, in this case, x over t. Okay? But I don't know t. So that means I need to solve for t over here as well. So that's is the other thing I'm going to do. I am going to, we already know our y displacement, so let me erase that. Our time, so again, I'm going a to b. Okay, so I'm going to use, if I want to solve for t, I'm going to use v equals vo plus at. Plug my numbers in. 0 equals 16.1 plus negative 9.8 times t. And t equals, okay, so if I 16.1 divided by 9.8, 1.64 seconds. Okay, but here again, here's where you got to use your picture. That's the time from A to B. If I want the time from A to C, then I have to double that. So my time from A to C would be 3.2, roughly 8 or 9, but seconds. So again, this is A to C. That's good because I want this and this to agree. Okay. Then I can plug my numbers in. 19.2 equals x over 3.28. So times 19.2, and you get your 63.1 meters. Pretty far kick, but doable. Okay. Bye, kids!